Revision Mid 3, Lesson 2, Chapter 1. Title: Concept of acceleration. Acceleration meaning that the relation between velocity and the time. Acceleration, speed and time, but I prefer velocity and time because they are vector physical quantity. After a second, say speed 3 meters per second. After 2 seconds, 60 meters per second. After 3 seconds, 9. After 4 seconds, 12. The meaning is that it is the regular. Types of motion. Zero acceleration, when the difference between two velocities equals zero, or initial velocity equal final velocity. Accelerating motion, this meaning that positive acceleration. Deceleration meaning that negative acceleration. Types of motion: acceleration and deceleration. Acceleration meaning that car speed increase at constant rate. This meaning that each certain value of time move by the same velocity. Deceleration meaning that decreasing speed each second or each interval of time until it stop. When it stop, V2 equal 0. Take care. Body move from rest, V1 equals 0. Use brake and the body stop, this meaning that final velocity equals 0. Definition of acceleration: dividing change on the car speed, not speed, velocity, and time in which change occurs. Acceleration is the value of a change of an object velocity in 1 second. Final speed minus initial speed over time. If the value equal positive, is the positive acceleration. If the value equal negative, it is called the deceleration. Unit: meter per second square. Why square? Because it is the speed unit, meter per second, divided by second. So we find second times second equals second square. Acceleration increase if the object speed increase by time. Decrease when the object speed decrease. Uniform acceleration. Example: bus moving in a straight line. The speed of the bus changes from 6 meters to 12 meters during a period of 3 seconds. What is the amount of acceleration? Acceleration equal V2 minus V1 over time. So 6 minus, begin from 6 to 12. 12 minus 6 over 3. 12 minus 6 over 3 equals 2 meters per second square. Finally, rules which stated before. We can use a triangle: distance equal velocity times time, or velocity equal distance over time. Velocity over time equal acceleration, or velocity equal acceleration times time. Physical quantity: scalar and vector. Scalar need magnitude only or number, while vector needs magnitude and direction. Vector. Example of physical quantity: mass, length, force. These factor or these words for both scalar and vector. Time, temperature, scalar and vector. Scalar physical quantity, mass, length, time, temperature, speed, distance, magnitude only. Don't need direction to be determined. We can add or subtract by the same measuring unit. Mass, length, time, energy, speed, and temperature. Vector need magnitude and direction. Example, weight, force, acceleration, velocity. Difference between distance and displacement. Distance is scalar, displacement vector. Speed and velocity. Speed letter S scalar, velocity letter V vector. Distance actual length, like distance, but displacement it is a straight line which connect between starting point and the end point. Okay. Distance take certain directions, but displacement it is straight shortest line between beginning and final point. Velocity vector. Average velocity equal displacement over total time. Velocity is a displacement in 1 second. Person covered 30 meters in direction of north in 30 seconds, then 60 meters in direction of the east in 20 seconds, then 30 meters in direction of the south in 10 seconds. Okay? Quickly, we'll give you some revision questions. Thanks.